All right, so I said we were going to be doing less work to solve the same constrained optimization problem. And we've already done a lot of the work. Can you believe that? What we have in this table is all the information that we need to create a system of equations that's going to tell us the optimal solutions to Otto Toyum's toy problem. The way we get our equations is to read the columns in our table. Remember, we have 3 limited resources in this situation, and that tells us we're going to have 3 equations in our system of equations. The first equation, let's check this out. I'm going to read down this list, and I know my first equation talks about wheels. And my equation tells me that every car uses 4 wheels, represented with 4x. Every truck uses 6 wheels, represented with 6y. And I know we have 36 wheels total that we can work with. So the number of wheels in my cars and trucks, ideally, meaning in the best case scenario, should total up to 36. The number of wheels I use in cars plus the number of wheels I use in trucks is 36. And we got this equation just by reading down our constraints column. This equation doesn't describe cars and trucks. This equation describes how many wheels we use, so keep that in mind. We take information from cars and trucks, but the equation is telling us about wheels. Okay, I said we had 3 equations in this system, so let's look at our seats column, and let's find our second equation. With seats, I know that every car uses 2 seats, so 2x has to be part of my equation. Every truck uses 1 seat, so I need a y here. And we're talking about all the seats that we use for cars and trucks, so we have to add these together. And again, in the best case scenario, I want to use all 14 seats. So this should equal 14. 2 seats per car and 1 seat per truck, and all together, I want to use 14 seats. And at this point, I hope that you can look at our table and see the equation that's going to arise as we describe our tanks relationship. So I'm going to change my color one last time. This time we're working with yellow. And let's read down the column, thinking about tanks. X plus 3y equals 15. And now we have ourselves a system of equations with 2 variables, 3 equations. One of our equations talks about how wheels are consumed. One of our equations talks about how seats are consumed. And the third equation talks about how tanks are consumed. And now, with just this little amount of work, a little bit of reading, which we have to do anyway, plus some organizing of our thoughts in a nice table, gave us 3 equations that we're going to use to find our optimal solutions in this constrained optimization problem. We're going to make the best use of our limited resources using these three equations. Let's get into the next video.